Here we have the 2.7 solving systems of equations using substitution. So for today's task, we're going to solve each system of equations using the substitution method. Now, to review what a system of equations is. A system of equations is when you have two or more equations that are working together at the same time. And how we group those together is this bracket, okay? And this is called a curly bracket, okay? In other words, sometimes it's also called a brace. And so anytime you see this, you know that you're working with a system. And so the other thing we're going to talk about is the substitution method. In this class, we're just going to talk about the substitution method. In future classes, we might talk about other methods to solve systems of equations. So for this first problem, we're going to go along step by step, and I'm going to write in words on the right side what we're doing. And on the left side, I'm going to do the math. And we're going to do a few examples, and then you'll complete your assignment. So question number 1, we have y equals negative 2x plus 9 and 5x minus 2y equals 18. And note that you can stop, pause, and fast forward at any point that you need. Step 1, you are going to substitute the expression solved for a single variable into the other equation. You're going to substitute the expression solved for the single variable into the other equation. So that means we're going to take this expression that is solved for a single variable, and we're going to substitute it in for that variable of the next or other equation. So we're going to take negative 2x plus 9, and we're going to substitute it for y in the second equation. So what will that look like? So we will have 5x minus 2, and rather than times by y, we're going to times by negative 2x plus 9, and it'll be equal to 18. From here, step 2, you're going to solve for the remaining variable. Now, in order to solve for the remaining variable, because you just substituted in your expression, you're going to have to distribute that coefficient to each part. So you're going to get 5x, negative 2 times negative 2x is going to be positive 4x. Negative 2 times 9 is going to be negative 18, and that's going to be equal to 18. From here, we're going to combine like terms. We get 9x minus 18 equals 18. And now we're going to move our variables simplify to have our variable isolated. So I'm going to add 18 on either side, which would give me 9x equals 36. And then we divide by 9. So x equals 4. From here, we're going to complete step 3. Now that we've solved for our first variable. So step 3, we are going to substitute the variable value that you just solved into one of the original equations to solve for the unknown variable. That was a lot of writing there. Substitute the variable value that you just solved into one of the original equations to solve for the unknown variable. So we're going to take this value of 4 and we're going to substitute it back into one of the original equations to solve for the remaining or the other unknown variable, which would be y. So when we're substituting, it's going to make more sense to substitute back into the one that's already isolated, like the first example, or sorry, first equation. So we're going to take y equals negative 2x plus 9, but I'm going to substitute 4 for x. Okay, and we're going to solve this. So negative 2 times 4 is negative 8 plus 9. And negative 8 plus 9 is a value of 1. So y equals 1. Okay. Last step, step number 4, is we're going to write the solution as an ordered pair. Now, an ordered pair is referencing when we graph things. So ordered pair is when you have both your values together and it looks like this. Parentheses, x, comma, y, parentheses. So we take our x value and our y value and put them together. And so my final answer would actually be 4, 1, in parentheses with a comma. And that would be my final answer. And so what the answer represents is an answer that works for both the first equation and the second equation. Based on our steps of substitution and solving, we're able to get that answer. If you need more time to copy down number 1, go ahead and pause. If not, we're going to move on to question number 2. Number 2, y equals negative 3x plus 5 and 5x minus 4y equals negative 3. Y equals negative 3x plus 5, 5x minus 4y equals negative 3. Now, if you would like to try this on your own, go ahead and pause the video, complete your steps, and then check your answers. If you feel like you need to be assisted a little bit more, feel free to do it step by step with me in the video. Okay, so step number 1, we are going to substitute the expression solved for the single variable into the other equation. So we're going to take this expression for y, and we're going to substitute it for y in the other equation. So that's going to look like 5x, oh, I apologize. 5x minus 4 times the quantity of negative 3x plus 5 equals negative 3. And then, much like the first one, the first thing you're going to have to do is distribute. So we're going to distribute that negative 4 to both terms. So 5x negative 4 times negative 3x is going to be positive 12x. Negative 4 times 5 is going to be negative 20. And that's equal to negative 3. Now at this point, I hope that you are closer to doing it on your own. So go ahead and pause it, try it on your own, and then come back and check your answer. Did you pause it? Did you try it? I hope you did. I can't check, but I hope you did. 5x plus 12x is 17x minus 20 equals negative 3. And then I'm going to add my 20 over. So I get 17x equals 17. Divide by 17 on both sides. And x equals 1. Now we're going to take x equals 1 and we're going to substitute it back into the original equation to solve for y. So I'll have y equals negative 3 times 1 plus 5. So y equals negative 3 times 1, which is negative 3, plus 5. Add the 5 and we get 2. Last step is to write this as an ordered pair. So my answer would be 1, 2, in parentheses with a comma. Hope that one went well for you, and I hope that you don't have any questions. If you do, make sure to contact me. Let's try number 3. Number 3, negative 7x minus 2y equals negative 13. X equals 2y plus 11. Now in this one, you'll notice that we have x equals versus y equals, which is fine because it's still isolated. So if you want, again, to try it on your own before I explain it, feel free to pause, try it out, and check the answer in a bit. If not, go ahead and follow along with me. So we're going to take our isolated expression and we're going to substitute it for x in this equation. Okay, remember this is for x, so we're going to substitute for x this time. So we get negative 7 times 2y plus 11 minus 2y equals negative 13. First thing we need to do is distribute our work for negative 7. So we get negative 14y minus 77 minus 2y equals negative 13. Then we need to combine like terms. So we get negative 16y minus 77 equals negative 13. To solve, we would need to add 77 to the right side, which will result in negative 16y equaling 64. We'll divide by negative 16, and y equals negative 4. Now we're on to step 3. We're going to substitute negative 4 back in to solve for x. So x equals 2 times negative 4 plus 11. 2 times negative 4 is negative 8. Add those together and we get a value of 3. So my answer, and be careful about which one's which, but it should be x first. So my answer should be 3 comma negative 4 inside parentheses. Hopefully that one went well for you, and hopefully you were getting the concept a little bit more. We have one more problem to do together, and I want you to try it all on your own. So please, after I write down the problem, pause, try it on your own, and check your answer. Number 4, x equals negative 3y plus 1. And the second equation is negative 3x minus 3y equals negative 15. Again, that equation is x equals negative 3y plus 1. And the second equation is negative 3x minus 3y equals negative 15. Go ahead and pause now and complete the assignment. Did you pause? I hope you did. This is awkward silence. If not, okay, let's go ahead and check our answer. We're going to take this expression. We're going to substitute it in for x. So we get negative 3 times negative 3y plus 1 minus 3y equals negative 15. Distribute. Get 9y minus 3 minus 3y equals negative 15. Combine like terms to get 6y minus 3 equals negative 15. Then we're going to add 3. So 6y equals negative 12. Divide by 6. And y equals negative 2. Then we're going to substitute in that negative 2. So x equals negative 3 times negative 2 plus 1. Negative 3 times negative 2 is positive 6. And 6 plus 1 is 7. So your final answer should have been 7, negative 2. I hope that one went even better than the last. And I hope that there were no mistakes or issues. If there was, please make sure you correct them and contact me if you have any concerns. All right, the last thing we need to discuss is special situations. So while solving, the variables might get canceled. If that occurs, and it results in a true statement, such as 2 equals 2 or negative 6 equals negative 6, the result is an infinite solution, which means that there's multitude of answers that could combo together to result in a true statement. The other situation is if that were to occur and it results in a false statement, like 2 equals negative 3, the result is no solution. Now, we've discussed these before in previous equations, so know that the situation could occur with systems as well. One of these or both of these could be on your assignments, reviews, or tests, so make sure that you're aware that they could possibly occur. Okay. those are it for today. I hope those went well. Again, if you have any questions or concerns, please contact me via email or come see me on another day. Have a great day. Bye.